All right, so we're going to talk about graphing quadratic inequalities. And so if you feel pretty confident about graphing linear inequalities or lines where you shade either above or below them, you probably don't even need to watch this video because it's basically the same idea except with quadratics. But let's go ahead and pull up a graph for this. Okay, so we've got a Cartesian coordinate plane here. Let's go ahead and start. So we know that the vertex happens to fall at 2, -3, because this is already in vertex form. So we know that the vertex is at 2, -3. And the reason it's 2 and not -2, remember it's x minus whatever the vertex is. So since it's x minus and it's 2 here, +2, then that's why the vertex is there at 2 then. So let's put that point. So 2, -3. So that's going to be right there. And from here, you got some options. You know, I happen to remember that quadratics, as long as this coefficient here, this number in front of the parentheses, the a value is 1, then you can go over 1 up 1, over 1 up 3, over 1 up 5, which is nice. That's a nice little trick. But let's assume that we're not going to use that. So all you have to do here is just make a table. When in doubt, make a table. Okay? So we'll get a little XY table going here. And what we're going to do is we're going to pick values of x and y that happen to be pretty close to the vertex values. Okay, so I'm not going to try like 12 for x because I know we won't be able to see the parabola. It'll be so high we won't be able to see it. So let's try like 1 and 3 for x. And in fact, if you do 1, then you don't have to do 3 because it's symmetrical. So whatever the y value is when x is 1, okay, so there's going to be a y value over here somewhere. Whatever the y value is there, it's going to be the exact same on the other side. So that's kind of nice. So let's plug in 1 for x. So we've got a y, and we're just going to do y equals for a second. I know we're supposed to do less than or equal to, but I'm just trying to graph the boundary of this inequality first. All right, so we're going to do 1. Let's get our correct color ink here. So we're going to do 1 minus 2 squared minus 3. And so that is, okay, so 1 minus 2 is -1, and if you square that, you get +1. Okay, so 1 minus 3, so that's -2. So since that's -2, so we'll go ahead and put that point down there. So 1, -2. Let's go ahead and actually graph the other side, which is going to be at 3, -2, since it's symmetrical. Okay, so 3 will also return -2 for us. Let's plug in another point right next to that. So let's try 0. And by right next to that, I mean we tried this one. Now let's move over to 0. Maybe we'll move over to 1 and 2. It depends on what happens here. Okay, so if we plug in 0 for x, we've got y is equal to 0 minus 2 squared minus 3. And that turns out to be 0 minus 2 would be -2. If you square -2, you get 4. And then you get 4 minus 3. So that's going to be 1. I'm also going to say that since it's symmetrical, when we plug in 4 for x, we should get the exact same number. So let's plot those. And let's try one more. Usually 5 points is enough, but I just like to have another one for precision. All right, so let's try, I'm going to try 5 instead of -1, right? Like you can go over here and do -1. It's probably going to come up somewhere here, over here. But 5 is also going to return the same value, and 5 is not a negative number. And I like not negative numbers. So, and I don't know why I'm throwing in -5, because I just said I like positive numbers. All right. So we've got y is equal to, now we're plugging in 5 for x, trying to see what happens for the y value. 5 minus 2 squared minus 3. That's going to be equal to, that's going to be 5 minus 2 is 3, and when you square 3, you get 9. So 9 minus 3, that'll give us 6 there. I forgot to put the 1 in there for the 4. Okay, so the value there is 6. So when we're at 5, the y value should be 6. The y value should be 6 here. Okay, and now let's go ahead and connect the dots. So we'll draw a curve here. And we'll draw the curve here. Not the best, but you get the idea. And so now what we've got is we've got every point on this black curve here is such that the y value is equal to the x value subtracted by 2 squared, and then subtract 3 from that. Okay, so any point on here is the point where the y value is equal to that. We want the places where the y value, we want to show on this graph here, the places where the y value is less than or equal to the x value minus 2 squared minus 3. Okay, so if I wanted the place where they were all equal, I would just graph the parabola. If I wanted the place where the y values were greater than x minus 2 squared minus 3, I would shade above the parabola, right? Like if you think about this point right here, if you plug in 1 for x, you get exactly -2 for y, okay? But you can imagine if I crank the y value up to 5, that the y value is now going to be greater than x minus 2 squared minus 3. Right here it was equal, but up here it's greater. So if I wanted y is greater than x minus 2 squared minus 3, I would shade up here. Since we want y is less than or equal to x minus 2, we're going to shade below the parabola. Okay, so we're going to shade like everything that happens to fall below the parabola. All of this stuff. Okay, and that's going to be the solution to our quadratic inequality. Some of you may object, hey, this doesn't look like it's below the parabola. Well, the parabola goes up forever that way. It also goes up that way forever. So I didn't shade everything I should have. I mean, I technically should have shaded here and should have shaded here. I just didn't want to color past the lines. Otherwise, my daughters would yell at me. Okay, here, fine. I'll color really close here so that we fill all that stuff in. But that's the idea here. All right, so some of the functions that you're going to get are not going to be in nice old polished vertex form. So this one comes in standard form, and we can actually technically rewrite this one in vertex form pretty easily. So you could just say y is greater than 1x minus 0 squared minus 3. And again, remember, your vertex is going to be these 2 points right here. So the vertex will be at 0, -3. So boom, you're going to go 0, -3. And since this value here is 1, this is going to graph like any parabola. It's going to go, and I am going to save us some time here. It's going to go over 1, up 1. And then it's going to go over 1, up 3. And then it's going to go over 1, up 5. Just a nice little trick there for you. So let's go ahead and draw the lines there, or the curves, I guess. Okay. I feel like I drew that one a little better than the last one. Okay, and now on this one, I did make a little mistake here. So we got to go back and correct it. This is saying that it wants all the y values that are greater than x squared minus 3. So we will be shading above this parabola, but before we do that, it says just greater than. So we can't actually include in the solution set any y values that are equal to x squared minus 3, which is what I've done here by doing a solid parabola. So remember, just like our linear inequalities, if you have a greater than, you want to make sure that you have a dotted line here, or a dashed line. So I'm just kind of drawing in some, erasing some stuff here to make this look dashed. Could look a lot better, but you get the idea. All right, so that's a dashed line. And now, since we only want the y values that happen to be greater than x squared minus 3, and anywhere along this curve is where the y values are equal to x squared minus 3, anything that falls above this parabola would be in our solution set. So if you try any xy coordinate pair up here in this area where I'm shading it in, and you plugged in the xy values, they would be true. And I'll show you what I mean by that in a second, once I'm done shading this little tornado looking thing. Okay, so what I'm saying is if you happen to pick a point, let's just grab one, like right here at, oh, I need my pen again. So if you grab a point right here at -1, 8, if you actually plugged in -1 for x and you plugged in 8 for y, this inequality here would be true. So think about it. So -1 squared is 1. 1 minus 3 is -2. Is 8 greater than -2? Yeah, it is. So that actually works, and that makes sense. And so what you'll find is that any point that you select in the area that we shaded will actually work for this inequality. Any point that you select in the that's not in the shaded area would not work for this inequality. All right, so now we have a system of quadratic inequalities. Let's graph both of them and then see what happens. So let's tackle this red one first. So we've got y is greater than or equal to 1/2 x minus 3 squared minus 1. The nice thing is, hopefully you guys are kind of catching the pattern here. The vertex here, so the vertex for our red guy is going to be at 3, -1. So let's actually plot that now. 3, -1 is right there. How about for our blue? The vertex is going to be, since it's in vertex form, the vertex is going to be at 4, 3. So 4, 3. Let's go ahead and graph that. So those are our vertices. And let's actually plot the blue one. The blue one's going to be pretty easy. The only difference between the blue one and a regular parabola that would go up like this, where it goes over 1 up 1, over 1 up 3, over 1 up 5, is that this one is going to get flipped upside down. This negative here flips it. So let's go ahead and graph that. So the blue one, we're going to go over 1, and then instead of going up 1, we're going to go down 1. And then we're going to go over 1, down 3, over 1, down 5, over 1, down 7, but I think I'm out of room. So over 1, down 1, over 1, down 3, over 1, down 5. And let's go ahead and draw the line there for that parabola. And this one is going to be less than or equal to. So I can actually shade the line in solid. I don't have to do a dotted line. Alright, so we'll try to graph this as best as is possible. That was pretty good. And so now we have a little bit of a difficult, not really difficult, but kind of annoying task to tackle, and that's dealing with the 1/2 here. So what I'm going to recommend that you do for these is that you pick a point, instead of picking a point that's over 1, pick a point that's over 2. And the reason I'm getting 2 here is because of the 2 here. So if it was 1/3, I would pick a point that's like 3 points over and do that. It'll probably become a little more clear why we do that here in a second, but I'm going to actually scroll down just a little bit here so that we can make a little XY table for our red function here. So let's pick a point 2 points over from the vertex. So right now the vertex is at 3. Let's try something. Let's try 5 for x and see what we get when we plug in 5. So we've got y, and we'll do equal here just for a second. We're going to do 1/2 of, specifically I want to try 5 minus 3 squared minus 1. So this is going to be 1/2 of 5 minus 3 is 2. If you square 2, you'll get 4. So half of 4 minus 1, trying to save us some room here. Half of 4 is 2, minus 1 is 1. Okay? So when we plug in 5 for x, we get 1 for y. So let's go ahead and do that. 5 for x, 1 for y. And since it's symmetrical, since we went over 2, up 2, we can do the same thing here. Over 2, up 2. And now let's go over 2 again. So we are now at 5. Let's go over to 7 and try it. You're more than welcome to try other values, like if you wanted to try 4 or 6, you could. It's just going to give you a decimal since you've got the 1/2 going on here, and that's just kind of annoying. All right, so all right, I'm going to do 7 down here. So we got 1/2 of, I want to try the 7 value for x, minus 3 squared minus 1. So that's going to be 1/2 of, okay, 7 minus 3 is 4. If you square that, you get 16. So half of 16 is 8 minus 1. That gives us 7 here. So over 2, we're going to go up to 7. So that would get us right here. 2, 7. And I went over 2, up 2, over 2, up to 7. I'm not saying I'm going up 7. I'm technically only going up 6, but this was over 2, up 6. All right, so now we have enough points for our red parabola to go ahead and graph that. All right, so this parabola is going to be a little fatter. Okay, and so let's kind of, oh, no, that's not what I want to do. Let's zoom back out a little bit here so you can see everything we've done so far. Okay, so these are our 2 parabolas, the red one and the blue one. Unfortunately, we're not done yet. We need to shade for each one of them. So let's shade for the red one now. So if we shade, and I'm going to try to use like a red colored pencil here. If we shade everything, we're going to shade above the red parabola. So we're going to shade, go a little bigger here. So we're going to shade everything up here for the red parabola. And that's, I think, a little darker than I had hoped for. What about the blue parabola? So we've got the blue parabola here. This is less than or equal to, so we're going to actually come down and we're going to shade a little smaller and not quite as dark for this one. So the blue parabola, we're going to shade everything below the blue parabola because it was less than or equal to. Okay? And now the question is, where is the overlap area? Or in other words, where are both inequalities shaded in? Well, it would be this weird sort of overlap between the two. So what we're going to do is we're actually going to shade. When you shade, hopefully you'll shade your red and your blue pretty light. And then what you want to do is you want to shade this part in really dark because this black part here is actually the solution set. If you pick any point, any xy coordinate pair within this little black space here, it will work for both inequalities. If you pick a point up here in the red space that's not down in the black space, it will only work for the red, not the blue. If you pick a point down here in the blue space, like 5, -5, it'll work for blue, but it won't work for red. This will be false. This will be true. If you pick a point out here that's in neither, it will work for neither one of these, okay? So the solution set then, technically our answer would just be this black part, and you would kind of either erase or disregard the very light shading of the red and the blue. All right, so this one's a little different. This one's kind of backwards. It says to write the inequalities for the graph to the right. So instead of getting the inequalities over here and graphing it, what we have now is the graph, and we're going to try to work backwards to figure out what the inequalities are. So let's start with the blue one here. The nice thing about the blue one is it has a pretty clearly defined vertex there. It appears to me, sorry, I got to grab my pen here. Looks to me like the vertex is at about 1,5. So for the blue, the blue vertex is at 1,5. And so that means at this point we know we've got y is equal to a times x minus 1 squared plus 5. The only thing we would need to specify now at this point is a. We don't want to have a letter here for a. We want to have a number here. Okay, the x is fine, the y is fine. 1 and 5 are both great. So I'm going to give you a little trick here. notice, look at the blue parabola with me here. I'm going to go over 1, down 1, and then over 1, down 3, and then over 1, down 5. That is a standard parabola, and by that I mean the a value happens to be 1, okay? The only difference here is that the a value is -1 because this one's opening upside down, okay? So that is a nice little shortcut. You can use the same method that I'm about to use on the red parabola to find a, but that's just a lot quicker. So the blue one here is going to be -1 x minus 1 squared plus 5. That is the blue parabola, okay? Now, that's the, notice how I'm putting equals here. I shouldn't really be putting equals because we're not taking all the places where the y value is equal to the, -1 times x minus 1 squared plus 5. We're taking all the values that are less than or equal to. So I need to actually change this to say less than or equal to. So let me erase that. So that's going to be less than or equal to because we're shaded below. The reason I'm saying less than or equal to is because we're shaded below that parabola. All right, so there's your blue. How about red? So does red have a clearly defined vertex? Yeah, it looks pretty good about right there. So that's at -2, -3. So for red, the vertex is at -2, -3. So right now at this point, we could say y is, I'm not going to say equal. Can we all agree here? This is, we're shaded, if you look at this dark shaded area, it's shaded above the red parabola. It looks to me like what they did was they shaded everything above the red and below the blue, and the intersection was just the stuff right here, this black part. So let's go ahead and say that this is going to be greater than or equal to, because we know we're going to have shade above the red. I don't know what the a value is yet. Definitely we do have x minus -2 though, plus -3. So let's simplify that a little bit. That's going to be y is greater than or equal to a times x plus 2 squared. And then I'm just going to say -3 because that's the same thing as plus -3. Now the only thing we need to figure out is this a value. Now the problem here is when we go over 1, we're not going up 1. So the a value is not going to just be 1 here. It will be positive because this parabola opens up, but the a value is not going to be 1. So we're going to have to do some work to figure out the a value. So I'm going to scroll down here a little bit. And what we're going to do is we're just going to look at the red parabola. And what I want to do is I want to select another point that happens to fall on the red parabola. I'm going to pick right here at 0, -2. So we know that 0, -2 is on the red parabola. What does that mean? Well, the red parabola, if you had an equation for it, would be y is equal to a times x plus 2 squared minus 3, which is fine, except we just don't know what the a value is. But what we're going to do is we're going to use the xy coordinate pair here and plug them in for the x and the y, and that'll tell us what the a is. Okay, so y, which is -2, is going to be equal to a times x, which is 0. So all I did here was I filled in the x value was 0 and the y value was -2. So now what I'm going to do is I'm going to solve for a, and then we'll get back to our answer. Okay, so this is going to be -2 is equal to a times, okay, 0 plus 2 is 2. If you square that, you get 4 minus 3. So -2 is really just 4a minus 3. So if we add 3 to both sides, we'll get 1 is equal to 4a, which means that a is 1/4 if you just divide by 4 on both sides. Okay, so a is 1/4. So that's good. That lets us know that now we're saying, not a, we're saying for our inequality, we're going to say that y is greater than or equal to a, which is 1/4, and then x plus 2 squared plus 3. And so that's going to be our red parabola inequality. Okay, so those are our two answers there. Okay, let's look at one more example, kind of like this one, but it looks a little weirder. All right, last one here. So write the inequalities for the graph to the right. And so this one's kind of interesting. It looks like what's happened here is we've drawn this red parabola and shaded below it, and then we drew the blue parabola and shaded above it. And so let's go ahead and figure out the equation for the red parabola first. So the red parabola, my pen here, has a vertex at 2, 1, which I'm coloring in right there. So red's got a vertex at 2, 1. And look at that. It's got that nice feature that we like with parabolas. It goes over 1, up 1, over 1, up 3, over 1, up 5. So it's just got a standard A value of 1. So when we write it in vertex form, we're going to say that it's 1 times x minus 2 squared plus 1. That's if we're equal. We don't want to be equal. We want to be, on the red one, we want to be less than or equal to. We want to shade below. So we're going to say less than or equal to. We don't really need the 1 in front of the parentheses there. Like if you just wanted to say x minus 2 squared plus 1, that's fine. How about the blue one? All right, so the blue one, it looks like it's got a very nicely defined vertex down there at, where is that? That is 2, negative 5. So for blue, the vertex is at 2, negative 5. And from here, unfortunately, it's not a nice over 1, up 1. What's like a nice clean point that we can grab? And by clean, I mean like this right here. That point right there is not on a grid pair. I would say if we look around, it looks to me like that right there is locked in. That one's pretty close, but I don't think it's quite right on. I would say that one right there is right on. We don't have to go all the way up there. Let's just take this one right here at 5, negative 2. So we definitely know that it goes through 5, negative 2. It's weird that those are like backwards flipped there. All right. So let's write the equation, actually the inequality, not the equation, because we're supposed to shade above the blue. So we know for sure this is going to be y is greater than or equal to the a value, which I'm not sure of right now, but I do know for sure that it should be x minus 2 squared plus negative 5. I'm just going to write minus 5. And I got the 2 and the negative 5 from the vertex, right? So with the vertex, the x value of the vertex goes there, the y value of the vertex goes there. Now we need to find a. And the way we find a, whoa, take it easy there. The way we find a is we take our knowledge of the fact that this right here holds when we plug in 5 and negative 2 for x. So we'll do that. I'm going to briefly change this into an equal sign for just a minute. So I'm going to say y is equal to, and I'm not going to do y. I'm going to do negative 2 because that's the y value of the point. That's going to be equal to a times not x. I'm going to put in 5 minus 2 squared minus 5. So I took the x and the y from here, the x and the y. I'm plugging those in there. All right, so I've got negative 2 is equal to a times, let's see if we can simplify this. 5 minus 2 is 3, and when you square 3, you get 9 minus 5. So basically negative 2 is equal to 9a minus 5. So if you add 5 to both sides, you'll get 9a is equal to 3. And then if you divide by 9 on both sides, you'll get that a is equal to 3 over 9. I'm just going to write that as 1/3. So if a is 1/3, then let's come over and write our inequality. So we're going to have y is greater than or equal to 1/3 x minus 2 squared minus 5. And so this right here will be our answer for the blue parabola.